Morning, everybody.
We go, Paul.
Rob, that kind of sounded like you coughed.
Oh, I said, how's it going, Paul? I
Ah,
need
yeah.
to enunciate better.
What?
I was surprised to see you sending emails yesterday on a holiday.
Yeah, I just wanted to get it out of the way.
Uh, I was even more surprised to see Jim doing it. I mean, he's retired, for crying out loud.
Yeah, but he's working. He's the editor of every standard we have right now.
Oh, well, good for him.
Yeah. I finally got a Wi-Fi extender, so I'm hoping to have decent bandwidth for my office here.
Oh, who's your carrier?
Well, AT&T, we've had the same Wi-Fi router for 7.5 years since we bought this house, and it's okay, but the new laptop the company gave me a few weeks ago seems not to receive as strongly as the previous one did.
Uh,
Anyway, now it seems to be working fine.
should upgrade to their 5G, which is what I have. It's actually pretty good. It's got good coverage.
Yeah, it's like 20 some odd dollars more a month to do that. And I'm a little leery because I also have AT&T for my personal cell phone, and it doesn't show
Mm-hmm.
a very strong 5G signal here.
Oh, interesting. Okay.
Yeah. I don't know if that's relevant or not. Probably.
Well, yeah, because the receiver is using 5G and
Yeah.
obviously Wi-Fi in your house. So yeah,
Yeah.
that would probably be an issue.
Yeah. Yeah. They keep haranguing me about, switch over to our new good thing. But
Yeah, yeah, they're trying to go copperless. So, but it works really well. So, in the throughput,
wow.
my bandwidth is actually really good. Till once in a while it gets loaded down. I go, what the hell happened to my? It's like
Yeah.
4 megabits per second, and as opposed to the 200. So, but that's pretty rare.
Yeah. We also have wireless electric meters and water meters here. I don't know if they're
Oh wow,
choosing 5G or not. Maybe the city
interesting.
has some private network,
Uh
but I wouldn't think so. Never know.
huh.
Hey Jeff, I'm here if whenever you want to start. This is Prashant.
Oh, excellent. Thank you. We'll wait just a couple more minutes and then get going.
Since I'm not very used to Zoom, I'll just share my screen so so that we don't get surprises at the last minute.
Sure. Yeah. And actually, once you got that up, we can probably just get into it. I'll give an intro. So this is Prashant. Welcome to OCP Security, and today's topic will be the attestation version 1.1 document, which has some updates about SPDM.
Let me just share my whole screen. If this works, let's see. Can you see this?
It's coming up. Yep, we can see it.
Hey, hi. So I'm Prashant. I'm in Microsoft, and this one I'm basically representing my manager, Darpana. I think she worked on this with many of you guys. And the document, I don't think there is anything surprising in the document, but the specific thing we need to talk about is this get CSR. It allows, and there was a lot of discussion whether we should have this get CSR in this spec or not. Get CSR, as you know, allows the requester to ask a device to be able to provide the CSR, and then the requester can use their PKI system to sign a certificate, and whatever mechanism they have, they can use it to provision it. This became a discussion point because the way it was written in the SPDM spec, I believe get CSR required that the device should send a device ID. I mean a device key, and and as people started implementing it, it turned out that that device key, the signing key was not available at the runtime, because it generally gets locked by ROM, and that is where the whole discussion started. And now the way this is written is that any key that is endorsed by the device ID key, and to me an example would be an alias key, could be used as a response to the get CSR. And the CSR may be null sign or I mean, instead of being self signed. And I believe in a practical implication would be that key would have some binding to the manufacturer, such that when a PKI system receives the manufacturer certificate and this key, they can figure out that the key has been generated from a specific device. So this is the summary of this get CSR change, and I know Jeff here knows more about it than I do, because Jeff, you've been in various forums. So if there is anything you wanted to add.
Yeah, I mean, I guess yeah, I think you kind of summarized the problem pretty well. Does anyone? So yeah, just to summarize just kind of what it says there. The SPDM specification basically says you've got to yield a CSR over something they call the device certificate CA key, which the spec authors imagined would be the base DICE cert for the device. That is more tractable when the base DICE key is wielded by FMC, because you can update FMC if you need to subtly tweak your X509 generation logic to make a CSR properly. But then when you start putting DICE key generation stuff in ROM and starting the chain there, now it becomes a lot more hard. Like if ROM is configured to sign an alias key cert and then throw away the device ID key, because that's what you should do with dice generally, then patching up ROM to also do the get CSR thing with that key is problematic. It adds complexity, boot time is impacted, etc. So does that problem make sense to folks? Or does it not make sense to anyone?
I guess the question I've had since the beginning of this is like the problem makes sense as you've stated it. The question I've had that I've not really, I don't feel gotten a satisfactory answer to is the spec currently implies providing a get CSR for what is an embedded CA cert, not a leaf cert. And I still haven't understood what is the value of the get CSR for the embedded CA. I understand how a get CSR for a leaf cert would work and how it would be used. I still don't understand how you're going to use a third-party signed cert over an embedded CA.
My understanding of how this is used, and this is not what Google does, so if someone's doing this, please correct me if I'm wrong, but though how I understand it's supposed to work is when the device comes in through the front door into a data center, the operator wants to issue their own certificate over the embedded CA's public key. So the certificate chain now routes through the operator instead of the vendor. So if the vendor's PKI is compromised in the future, that is of no consequence to already deployed devices.
But that's not a true statement.
Okay.
If you are endorsing an embedded CA, you still need to be evaluating vendor signed RIMs in order to use the certs that it generates.
Well, I was kind of deliberate when I said if the vendor's PKI is compromised in the future, that is the goal is to not affect already deployed devices. Like this has already been done to. If the vendor's PKI is compromised in the moment when you're ingesting a device, then yeah.
No, but every time a DICE embedded CA is used, right? So every time you reboot, you generate a new leaf cert with the TCB info field, and that TCB info field has to be compared against a RIM, and those RIMs are still signed by the vendor. And that's
Sometimes.
Every time you use that leaf cert, you have to do that evaluation.
Yes, although the RIMs can be rooted, I mean, they don't have to be just purely signed by the vendor. They can also be signed by a safe auditor. They can be like built from source.
Maybe. I don't think the verifier infrastructure to support that actually exists today. I'm not even sure the policy infrastructure to support that, like to write the policy that way exists today.
I mean, yeah, I know it's not like
my
that way, but
my point is third-party signing of an embedded CA is very different in what it delivers to the consumer of the cert chain than third-party signing of an alias cert. And nobody's actually pointed out how they plan to use this in a way that doesn't look ineffective.
Well, I guess the question for that, like, let's say the alias cert itself is going to sign other evidence, which would be covered by a RIM, right?
The alias cert is going, potentially, it could be used directly for all sorts of things.
Right, but I mean, a common use case is SPDM where you're signing measurements.
Sure.
So I think you have the same problem there, right?
Maybe it depends on how you're getting your references.
Right. So yeah, I think that's the answer, right? It really depends on how you're getting references, whether for SPDM measurements or alias cert measurements. Because yeah, if you're getting them from, if you're getting all your reference measurements from like a vendor signed RIM, then and you're not verifying it against anything else, then yes, the vendor PKI gets compromised, your measurements are all suspect.
So just I want to ask, this device certificate is the UDS certificate in DICE, or which one you're referring to here?
Yeah, so let's be clear on that. The device, when you say like device ID,
It's just
key?
like, yes, say PUF, we generate a UDS and then we get a DICE certificate, right?
Yes.
UDS certificate, whatever.
Yeah, so like when I say device ID certificate, what I mean when I say that is or the device ID key, which is it is the bottommost key in the DICE hierarchy. Now I think it's implementation dependent whether that key derives exclusively from UDS or whether it also derives from UDS
FMC,
plus
FMC
measurements, right?
Yeah.
Like in many devices, it derives from both because you start DICE at FMC.
Yeah.
Calyptra, though, and other devices would start it in ROM. So the only thing that contributes to the device ID key would be UDS.
Yes.
Yeah.
And then we have LDEV ID also, right? Like that record we just put some entropy bits and you generate for the
Yeah. So there's another
local device
measurement there,
certificate. Yeah.
and then there's FMC after that. Yeah.
So all these certificates are actually finally endorsed by the vendor, right? Using their PKI infrastructure.
The vendor PKI is yes, their job is to endorse this hierarchy of certificates. The get CSR function or command, the intent is to allow someone to re-anchor off of their own PKI.
Okay.
And not everyone, it's an optional command, right? It's optional in the base SPDM specification. And it's even, even if a device supports, you don't have to use it. You can just continue to trust the vendor PKI and not bother provisioning your own certificate. And if your certificate, device or provisioning onboarding infrastructure is sophisticated enough, you don't even need this command to do the certificate re-anchoring. Just say, okay, I understand the device I'm talking to controls this device ID key because I just did an SPDM challenge to it. Let me go issue my own certificate for it now. But not all certificate issuance infrastructures are built that way. Some of them require an actual X509 CSR to function.
Hey, Prashant.
Yeah, hi.
Prashant or Jeff, sorry, this is Lance at Micron. I was just hoping you could go into a little more detail about what's meant by the null signing of the CSR. I think you may have said that that's okay if the certificate authority has some other evidence that a valid key is coming in and can therefore generate a certificate. It wasn't clear exactly what you meant though, and I don't know what the term null signed implies. Sorry for my lack of background, but could you elaborate on that?
I can elaborate what I mean and then turn over to Prashant to expand on that if you'd like. So
please, thank you.
Yeah, I mean, null sign just means most CSRs in particular, like web PKI, are generally self-signed. They use the key to sign itself, prove control of that private key.
Yep.
That's problematic on embedded devices where.
No, I get that part.
Yeah.
I just don't know what. Yeah. Does it mean there's literally no signature? Is that?
Yeah. So I guess it means like the key that's for which the CSR is minted does not need to be used to sign the CSR, and the specification is it's underspecified exactly how else you would prove control of that private key. So because there are different ways, and we didn't choose to write them all down here. So I guess it's a fair question. But Prashant, if you had anything else.
No, yes, the evidence for that key will have to be obtained out of band. I mean,
Okay.
yeah.
Okay.
So presumably the CA would receive evidence that this particular device whose public key that you're seeing via the unsigned CSR is actually a valid public key, and therefore the CA can go ahead and issue a certificate. Is that
Yeah,
fair?
yes.
Okay. One other just related question, and maybe this is done every day, but if I consider a CSR without a signature, is that something that typical PKI tools handle, or will that cause, is this sort of a new concept that might cause tools to choke? And I'm not implying anything. I'm just trying to understand if that's commonly done.
Yeah, like will OpenSSL accept it?
Exactly, or other tools if they see this formatted unsigned CSR thing.
So I don't know the direct answer to that. Maybe I can take an action item and see what does OpenSSL do when it receives a null signed CSR. I don't know right now.
Okay, thank you. Appreciate the response, guys.
Sure.
And just to, I guess I can close the loop. Like one thing that we can do, or one thing that can be done, you can put like an SPDM aware validation authority in front of your CA and say, hey, look, I saw an SPDM transcript hash signed by this certificate chain, has the nonce, so I know it's fresh. I know the device is in my possession and it controls this cert chain. Ergo, I'm confident that I can issue a cert for this device key.
Do we need the device to issue the CSR if that exists?
Yeah, that's a good question.
So
you could just,
yeah, so there are a couple of those. I mean, you know, the idea of a you know, some kind of sophisticated infrastructure that can just produce correct certificates. I mean, that was contemplated, right? That this is why get CSR and set certificate are separate capabilities. You may have the ability to receive a certificate without actually having the associated get CSR command because your infrastructure might be sophisticated enough.
mm-hmm.
I
mean,
yeah.
Sorry, go on.
Well, then something we do want to consider here. So SPDM has a way that was at least envisioned as a way to get out of the problem of not having access to the device key. It's not perfect in itself, but there was an envisioned route, and we definitely need to at least contemplate it in here. And the route was to take a reset. You know, because that's really your path to, you know, assuming that you're not generating your device key out of your ROM and you're generating out of the FMC, that's your route to get back to the FMC and regain access to the device private key.
Right. I mean, I think you need a lot to make that work, right? Like
it's not simple. Yeah.
Yeah. You need to reset. You need like some kind of signaling system back to FMC or ROM. I mean, ROM could do this too.
Yep. Yeah, and yeah, maybe. Yeah, I think the idea of a, you know, I think we want to make sure we allow that flow, but the idea of a null signed ROM and then some kind of external verification, that's an interesting idea. Right, that's a kind of simpler way to just cut through the path here.
Mm-hmm. And Prashant, I don't know if you want to comment on like the utility of get CSR that yields a null signed CSR.
Yeah, I think our infrastructure does support it, but I think somebody asked a very good question. How will OpenSSL still behave in that scenario? I really want to go and check if it will ignore it, it will reject it.
Okay.
So what is the motivation for allowing this null signed CSR?
I mean, the motivation was to allow a device to yield a CSR over a key that without having to take the boot time hit of signing the CSR. All right, boot time and complexity hit.
Okay, but yeah, the device still has to have signing logic. It's just that it's slow. That's the situation, right?
Well, it has signing logic because it's using the key to sign a DICE certificate. But then that's the only thing it needs to do with that logic. It doesn't need a whole nother system for signing a CSR sometimes.
Yeah.
Okay, this is all I had. I didn't have anything else. I believe this was the area we wanted to discuss in this spec. Jeff,
Okay, awesome.
sounds good.
Yeah,
Thank you so much for your feedback. Thank you.
If there's any other comments on the rest of the SPDM portion of the 1.1 update, just let us know.
Is 1.1 posted?
We'll send.
It is posted. Do you want me to put the link?
Yeah, I'll send a link out to the mailing list.
Here, I sent the link.
Awesome.
Here.
Okay.
Yeah.
But yeah, probably good to mail it too.
Sure.
Yeah. But yeah, thank you, Prashant.
Sure. This is my only useful thing I've done in the day since the morning.
Okay.
So one question about the CAs that receive this null sign CSRs, is there a mechanism for them to figure out that they can trust that and issue a certificate for that public key?
So there are mechanisms. They're not like written down and standardized, and not all infrastructure could support them. So like I described how you can have an SPDM aware VA in front of the CA that can look in an SPDM conversation and understand that the device is in your fleet and is using the key. You can also have just like a clean room environment where you just implicitly trust any keys coming out of it are authentic.
Right. I mean, the thing is that assumes that you have this CA infrastructure locally or somewhere that is trusted, right? Yeah. Or somewhere that infrastructure can trust that that is not being able to sign a CSR that is bogus, right? Now the question is, if you have a smaller provider that doesn't have this and has to go to an external CA for signing these types of things, what does that mean? Does that mean that the null signature case is not supported in that case, or does that mean that there is some other ways that have to be agreed between them and the CA for trusting that CSR?
I don't know the answer to these. This is a good
Jeff,
question.
I can try that if that's okay.
Yeah.
So yes, as Jeff was saying, this is not this is not standardized yet. So a small CA or a small vendor who needs to get this done will have some out of band agreement until there is a standard.
I mean, it sounds like it would be like nice to have something written down about, because otherwise device vendor is going to make something and then not know what the rules are for all the different CAs. I think that's a concern.
Yeah.
Is that-
Yeah, the thing is, I think for the bigger sites, right, that have their own CAs and that kind of stuff, this is not a problem. They can deal with it, right? Like, I'm sure Google can deal with it, Microsoft can deal with it, and so on. But when you have the smaller users, right, that don't have the infrastructure and that are using these devices that have these limitations, right? And there should be a standard way for them to be able to get the CSR signed. Otherwise, the CAs are just going to say, I don't trust it, right? I don't know.
Yeah.
If
Makes
you have
sense.
to do it with some kind of external, out of band agreement, then the agreement could be to ignore the signature, right? That instead of having an option of no signature, you could always have a signature and say, oh, well, if it fails, then we have an agreement with this company that we're going to ignore it. So
Yeah, so
yeah.
that's an option. I think the motivation for writing down maybe null signed was to try and ease the burden on device vendors, that like to allow their devices to be less complicated. So that's where that came from. But I mean, see that this is sorry.
Yeah, no, I was just going to say is from the other side, from the other angle, which is the CAs,
Yeah,
right?
yeah.
How do they trust this thing, and what does that mean, and how do you not put? I mean, it seems to me that the approach here is the CA has to have an agreement with X, and that X is going to send this unsigned CSRs, and then the CA is just simply going to create certificates for the public keys, right, for this guy, but not for everybody, right? So then you start getting into this, okay, how do you uniquely identify this guy, right? Most of those mechanisms are based on signatures and stuff like that, right?
Yeah, I see that the desire to have devices be less complicated is a bit in tension with the desire to have things really buttoned down and standardized on the CA front.
Right.
In this case. So it sounds like we do have an action item to figure out what the tooling will do about this. And we can, revisit the conversation with that data. And I think this is a good perspective about this tension. See if we can address this.
Sorry if I missed it. Is there some discussion of the formatting of a CSR that is null signed? Like I guess PKCS 10 specifically calls like a signature as a required field. So is that signature field zeros or is it something else?
That's a good question. I don't think we have anything written down about that at the moment.
Yeah, like you said, if verification of the signature fails, maybe that's treated as null signed, but maybe you want to distinguish between no signature and a failed signature.
Yeah, I'm going to add a comment. Sorry?
My understanding in CSR, RFC basically say the CSR should be signed.
Right? Yeah, it's a standard, or it's a required field.
Yeah. If you go against RFC, that is a different thing.
Yep.
All right, I'm adding a comment to expand on that.
And James, to make sure I'm understanding you right, you're basically saying there is a field that is designed in RFC. If you're saying null sign, what goes in that field?
Yeah, I had to check the RFC because my understanding, as per the RFC, the CSR message should always be signed using the product.
Got it. Yeah. That's a very good one. That makes sense.
Okay, I've added that, so we'll track that.
I guess I kind of have a related question, right? If it's null signed, does the device even have to produce the CSR itself? Can something else generate it?
Yeah, Prashant, if you want to speak to that.
If it's so in all of our usages right now, the device is generating it. Although I cannot think of a usage right now that somebody else might be generating it. If there is a usage, we can talk about it.
No.
Mhm.
If it's null signed, why, like, some third party could generate the CSR and collect the evidence and hand it over to the CA. Like, why does the device firmware itself need to generate the CSR?
I see. Even if it's not using the private key, the device has the private key. So if some third party is doing it, should we expect they also have a mechanism to inject that private key in the device?
But the CSR, because it's not signed by the private key, the CSR should, like, anybody should be able to construct the CSR, right? There's nothing special about the bits in the CSR that require the device to construct them if it's null signed.
Correct. Yeah, correct. And if somebody else is constructing it, they will have to give the private key to the device somehow, right?
Well, or the device publishes a
or they
private
know
key.
the
Public
why-
key, and yeah, if they know the public key, they can construct a certificate around it.
For the CSR, only the public key is necessary, the private key,
Correct.
why?
Yeah, you need the private key of the signer, but not of the cert itself.
Yeah. I mean, since we are saying that the CSR belongs to this device, the private key is supposed to be held by that device, right?
And it will be, but the device doesn't have to generate the string of bits. Like, there's nothing in the string of bits that requires the device's involvement that I can see here.
Yeah, I would agree with that. Yeah, yes, I would agree with that. That if the device has the private key and somebody else has the public key, they can generate the CSR on behalf of the device. This is what you are saying, Matt, right?
Yeah.
Okay, yeah, that makes sense to me.
Okay, I'm gonna leave another comment to capture that.
Like, I realize it might be simpler operationally if the device produces the request, but it doesn't seem strictly required if it's null signed.
Correct.
Also, it just occurred to me that it might be useful to have some mechanism for indicating whether the CSR should be expected to be signed or not. And you can inspect but depending on how we define how to frame the CSR, you can kind of inspect and say, are you signed or aren't you? But a capability bit of some kind might be nice. Okay. Neat. Any other comments we want to capture?
Yeah, I think along the lines of what you were just saying, Jeff, maybe part of this mechanism between the CSR generator or the eventual certificate user and the CA is that there's some mechanism for giving the CA a list of public keys for which it will sign certificates, right? I mean, that's the only thing is that's the point of the CSR anyway, right?
Mm-hmm.
But what you want is that when you get the CSRs that are unsigned, rather than just signing them or creating certificates and signing them, the CA will say, okay, what is the public key that is involved in this unsigned request, and am I authorized to generate a certificate for that key?
Yeah, that makes sense actually. To have a whitelist, right, of all the public keys.
Right, and that can be done offline and in some other mechanism, right? But
yeah, that makes sense.
Just writing stuff down here. Okay, cool. Captured that. Oh, and let me just, I'm going to send this to main list, but, oh, it's already posted. Okay, great. Awesome. Thank you, Prashant. Okay. All right. Any other comments? All right. Well, this feedback has been very helpful. Thank you all.
Thank you. Thank you so much for all the input. You guys have a wonderful rest of your days. Rest of your day.
Yes. All right. We'll give everyone 22 minutes back.
Thanks. Bye.
Bye, everyone.
Bye.